Cause-effect chain analysis is a tool to support or to document systematically our analysis of the situation when we have a problem and we need an improvement. So it starts with the formulation of the problem with a natural language. A bearing overheats. A wind turbine generates too much noise, or the lecture is too boring. That is what we call target disadvantage. This analysis tool forces us to ask why many times, to analyze the causes of unwanted phenomenon down to the root causes. Since we mostly work with systems, there can be many disadvantages, many components, and complicated cause-effect phenomena, relationships. Cause-effect chain analysis helps to find out one or several root causes that are responsible for most disadvantages and meditate on how to kill them. Cause-effect chain analysis is actually a blend of several tools or strategies that have been known for decades. I will try to briefly introduce at least three of them. Actually, the baby version of cause-effect chain analysis is known as asking 5 whys from Toyota. And the second one is more developed, and it is called a root cause analysis. It is mostly attributed to General Electric company. And the third one, the most rigid and academic, is called fault tree analysis. It is most systematic tool to, for example, to do debugging in coding. It is also used in fault management, and it has two important operators, operator OR and operator AND, to model causality more precisely. Actually, cause-effect chain analysis, in a way I try to share it with you, was introduced by Gen 3 company approximately 15, maybe 20 years ago as a system solving tool, system analysis tool. Actually, it has little to do with classical trees, except to the idea of 9-screen vision from Heinrich Altschuler. He always forced his students to think about the past when they analyze the situation now. Why? Because possibly it will bring some ideas of preventive problem solving, almost ideal, easy final result solution. Cause-effect chain analysis is used for situation analysis together with function modeling. It also can be used to define contradictions in the system or as a part of function-oriented search. Ask me why I'm standing here, and I can give you at least two simple, even naive answers. One could be because the floor holds me, and that would be kind of simple function model. But at the same time, I can answer the question because somebody brought me here 5 minutes ago, and this would be closer to cause-effect link. Function model is mostly a kind of snapshot of the situation, a kind of cream sign. Cause-effect chain model is mostly used to analyze the situation in time domain. It completes the stage of analysis of the situation. I can't help giving you an example from high-quality mathematics. If we have a static model of the situation, we have a kind of memoryless balance of forces that looks like a function model. But when we introduce inertia forces, when we introduce memory, then it brings to the stage the time. Because I was brought here 5 minutes ago tells you exactly about the times, about the memory. So it looks like cause-effect chain. Mathematical model of dynamic system could contain quantitative functions and cause-effect relationships both in one, but unfortunately, mathematical modeling is not what we have time for, qualification sometimes, or data. The algorithm of cause-effect chain analysis. The first step is the easiest one. We just formulate our problem, our target disadvantage, something we need to change, to improve. Let us first apply asking 5 why strategy or root cause analysis. The thing is that we just literally have to ask why and formulate the cause of this disadvantage. And repeat again. until we reach a kind of fundamental fact that is beyond our control, that is needless to analyze, because that's it. Because we are on the Earth and there is gravity, or because there is a vacuum in the space, or because light travels faster than sound wave. Let us call these fundamental disadvantages beyond our control as key disadvantage. So we can have a kind of linear chain from key disadvantage to target disadvantage. So what? The point is that if we kill the target disadvantages, the whole chain is killed. It is what is called in medicine cure conditions instead of treating the symptoms. There are two other reasons that to trace back from target disadvantage to key disadvantage and to discover where the problem started. First, moving from target disadvantage to key disadvantage, we move from one domain to another domain. For example, from mechanical problem to electromagnetic cause, from electromagnetic problem to chemical cause, and from chemical problem to, let's say, production organization cause. So we have a kind of chance to go out of the box where initially the target disadvantage was formulated. We want to go out of the box. Also, what can be hard to change in one domain could be easy to change in another. The second reason is a kind of common sense wisdom. Many have been trying to solve the problem in the domain where it was formulated, and explains why painkillers are still the most winning medicine. But a few have time or expertise to dive deep and to find the primary cause of the problem at the depth where no competitors are able to reach. It is almost all except one important add-on from Gentry Partner Company. There can be more than one cause. And in this situation, we should use operators or and to model the causality relationship between them. If both causes are needed to generate the disadvantage, we have to place operator and between them. And if they're independent, use operator or and repeat and repeat and repeat again, the same way until we reach target disadvantages. Now, the causality chain is much more complex. It is not linear because of OR and R relationship. It can have branches, it can have loops, so the whole picture looks like a graph or a network or a tree. We do like operators and there, because killing one of the cause would kill the whole branch, will kill the effect. And we don't like operators or in the scheme because killing one of causes will just reduce the effect. So, seeing the whole picture helps to find one or several causes or key disadvantages that are responsible for most target disadvantages. We have to start our problem-solving efforts exactly from finding them and trying to kill. As soon as we have a problem, we can immediately apply cause-effect chain analysis to systematically ideate how to prevent it. No other ideation tools described through our course are needed. And at the same time, we strongly recommend using cause-effect chain analysis after function modeling stage. So the problems or causes are described, explained, formulated in terms of system components and functions. Also, having developed the function model of our system, it is easy to see harmful functions there and try to eliminate them by using cause-effect chain analysis. Like function modeling, cause-effect chain can also help to automate formulating contradictions for the system. We mostly use cause-effect chain analysis when we have a problem, but it is interesting to point out that it can also be used in quite a rare situation when everything is just great. So we want to understand why something is just great. And cause-effect chain analysis can reveal an interesting secret not known before by us or even by anybody. The secret of, for example, very efficient way of doing something, or in other words, performing a certain function really well, can be adapted for other products or processes that we are designing. This trick can help a lot when we are working with function-oriented search tool, for example. Let us be honest. Cause-effect chain itself is not a magic tool. It's not a bottom to push and get the result. It does not help us to find the causes of the problem itself. It is just a mind map, a kind of template, a shopping list not to forget something. Field application of cause-effect chain analysis tells that very often we need to ask experts. We need to do some serious research to understand what are the reasons for certain problem. Like in function modeling, cause-effect chain analysis can take days, weeks, if not years. And at the same time, it is simple and it provides an understandable interface for interdisciplinary development team management.